Yeah. It's a question about how to find roots of complex numbers. I have some like a general info for you here. It is here. So if you have two complex numbers given an exponential form like this, two complex numbers r e I theta r1 e I is missing here. Let's just I theta 1. So I was missing here, but now it's in. If you have two complex numbers like so, and if they are equal, what do you know about the modulus? Well, I just already said it to you. About the modulus, you know that the modulus are equal, but the arguments, they sort of equal, but not exactly. They equal up to the multiple of 2 pi. K here, if I find it here, here it is. K here is an integer of any kind. So when you have two complex numbers in exponential form equal to each other, then when you equate the arguments, you have to be careful. You have to equate them up to this extra term, and you can't avoid using this term. And that's the reason for that. I'll scroll it up a little bit just for a second. The reason for that was up here, in fact, here. That was the reason for that, because the exponential of the number multiple of 2 pi is 1. So it doesn't really change the complex number. That's the reason for that. You add up this extra bit. Okay, back to here. Now, because of that, when you go after roots of complex number, you have to do it in a special way. Probably you know this way, but I'll remind this for you. So when you go after the solution of the equation like so, let me just bring it up a little bit. So z to the power n equal r e I theta. The answer to this is given by, so n here is an integer. If n is not an integer, it becomes really complex. But if n is an integer, the answer here, there will be it will be n different solutions. So that's why I index these solutions with index k. And the answer to this, you take the root of the modulus in here, but with the argument, you have to be careful. With the argument, you go like this. First, you take the argument and you divide this argument by n, something quite expectable. But yet, you have to introduce an extra term. And this extra term, these revolutions, 2 pi I k. And k here it is, k take here any values from 0 up to n take 1. So altogether you have n different solutions to this equation. You have to remember this all the time. When you go after the root of a complex number, you have n different solutions. And that's the general formula for that n different solutions. Here's the example. So we're looking at the equation like this. We need to solve this equation, and the solution to that was here on the left-hand side. So here's my number. Geometrically, that's the number I. Without saying much, you can visually identify that the argument of this, if you bring this number to the exponential form, the argument of this number pi on 2, here it is. It's the 90 degrees angle. So if you bring this number to exponential form, here it becomes looking like this. Z to the 7, left-hand side, and that's the exponential form of your number I. Now you follow that formula to the left, this formula. This one. If I follow that formula, just simply following this formula, theta here is pi on 2, and here is 7. I just follow this formula, look what happens. Z sub k, we don't have any modulus. We don't have any modulus here, so that's why modulus is gone. Pi I on 14, because we got theta on n is 7, that's why pi I on 14, plus 2 pi I k, and here goes my 7. That's the expression for all solutions of this equation. Altogether, we have 7 solutions. They indexed with 0 up to 6. Okay, formally speaking, we solve the equation. That's all they expect from us, unless they say find the algebraic form of that. Down here, I wrote all of the solutions for you explicitly. So for instance, if you take k equals 0 here, and you put it in here, the whole thing will here disappear, and the solution will be like this, just the first term. If you take k equal 1, when you put 1 in here, and you do the arithmetic, what the result will be? Pi on 14 plus 2 pi on 7. So the second root here will be 5 pi on 14. Here's the next one. So they go with the step 4 actually. It's the next one, next one, next one, and this is the last one. If you look closely at the arguments here, all of them spaced with the step 4 pi on 14. And that's the picture of all of these roots. I can now show you these roots. Look at this. I'll just take this one. And that's this root. Pi on 14 angle, it's this little angle here, it's pi on 14. Next one, which goes next in a row, this is the second solution in your equation. This big angle from the horizontal line up to here, it's 5 pi on 14, but the step from the previous solution is 4 pi on 14. That's this step. That's this step, 2 pi on 7. I can place all of these roots one after the other like this. And that will be geometrical representation for all of these solutions to the equation, to this equation. And that's why. Anyway, any questions? Yes, please.
Shouldn't the argument be between minus pi and pi?
Not necessarily. The argument between minus pi and pi it's a very special kind of argument. It's called principal argument. If the question doesn't specifically ask you have to find the principal argument, you don't have to make an effort to put the argument between negative pi and pi. So this question, it doesn't say so. That's why I didn't do that. But of course, as an extra thing, you can do this. You can just recalculate these angles, these values in the bottom part, making them principal, so making them sitting within. Actually, we have to exclude one of the ends here, so actually I have to put here. Sorry, my fault. I have to put here strict inequality. If you have an argument, theta, which matches this inequality, you call it principal argument. I mentioned it last time, I mentioned it again here. Principal argument, sorry. You call it principal argument like this. If question doesn't ask specifically for this, you don't have to do that, but if it does, you have to. And these upper arguments, they all okay, they all match these boundaries, but these bottom ones, they not. So we have to, if the question goes, find the principal representation or principal argument, we have to alter this, and for instance, I'll alter probably one of them for you. For instance, this one, if I alter it, it will be e to the power, what that will be? Minus 11. I'll trust you here, but I'll double check in a second. Minus 11 on 14. Here it is. And you can alter all of these arguments too in the same way by making them negatives if the question goes about the principal argument.